Check point 4. The PV diagram here shows 6 curved paths connected by the vertical paths. So let's see the figure. You have the PV diagram, and in this PV diagram you have 6 curved paths: A, B, C, D, E, and F. These are all the curved paths, and these are all connected by the vertical path. So you can see this side vertical lines, that side, the right hand side and the left hand side, you have the vertical lines. These two vertical lines are connected with this 6 curved path. Now what we have to do, which two of the curved path should be a part of the closed cycle? So you can take this curved path and you have to take only 2 curved path to form a closed cycle. And for that cycle, the most important thing, the net work done by the gas during the cycle is to have the maximum positive value. So when you find the closed path, that closed path must have the maximum value. That means positive work done you have to get. That means the maximum value is nothing but, if you want to get the answer for this net work done, you have to find the maximum area inside the loop or inside the closed path. Clear? So for this, what we have to do, we have to use the formula work done, which is equal to P dV, where dV is the change in volume, or we can say W, which is equal to P delta V. And we studied this concept in chapter number 18. Clear? So the most important thing, when you have these type of work done, sometimes it may be compression and expansion of the gas takes place. Compression means your delta V is less than 0, or your dV is less than 0, or we can say your work done is less than 0. That means the work done is negative. If you have the expansion part, your delta V is greater than 0, or you can say dV is greater than 0. So if you have this greater than 0, your work done for this will be greater than 0. Clear? Now what we have to do, let's see how many curves will give the compressed region and how many curves will have the expansion region. You can see here the curve A is moving in this direction. That means the curve A refers to the compression. So the arrow marks towards the left direction all are compression. So how many curves you have? A, B, curve A, B, D, and E. You can see all these curves refers to the compression part. And how many curves will have the expansion part, which is moving to the rightward direction? So which is C as well as F. C and F refers to the expansion. But here we are not going to give the answer for this. We have to give 2 curved paths should make a closed cycle, and that closed cycle, the net work done must have the positive value. So let's see when your cycle is going to the counterclockwise direction. So let's see this. Let's take this diagram. What is the diagram? Let's take the curve A and curve F. Actually, you can see the curve A is connected by the vertical line, so it is coming here. And let's see the F curve, and it forms the maximum. So maximum area will give the maximum work. But the concept here is it is in the counterclockwise direction. So in the counterclockwise directions you have, your work done is negative. It has the negative value. So that means the curve A and curve F, even though it has the greater area, but the answer is negative value. Why? Because the cycle direction is in the counterclockwise direction. So what we have to do, we have to see the cyclic with clockwise direction. So for clockwise direction, we can consider curve C and curve E. You can see curve C is coming in the expansion, and then curve E is going to compression. So when you consider this entire area will give the positive, or you can say the curve C as well as D also giving the positive value, but what is the area? The area is smaller. That's the reason we consider C as well as E. So when you consider this, the curve C and E, you can see you will get more area. And these are all the cyclic with clockwise direction. So when you have the cyclic as well as the clockwise direction, you will get more area. By the time your work done will have the maximum positive. Clear? So here curve C and E, C and E will form the closed cycle. That means more area inside the curve, which will give the positive value for net work done. Clear? Clear, brother? So it's very, very important. Cyclic, clockwise direction, positive value of the work done. Cyclic, counterclockwise direction, negative value of the work done. So here we cannot, even though we have the greater area for curve A and F, but the value of the work done, even though you have more area, but what is the work done value? It will give the negative value. So that's the reason we pick the curve C as well as E, because the curve C and E form a closed path, and in this closed path you will get some area, and the most important thing, you will get the positive value of the work done. So that's the reason we choose the curve C and E for getting the maximum positive value. So the answer for this question, the curve C and E, for we have to consider for the closed cycle. So your net work done will take the positive value. Why? Because in this loop you have more area. So this is the answer for this question.